Hello everyone. Hi. So having a nice time, right? So I'm Aditya Gupta and he's my partner in hacking. And so our talk is stand close to me and your pawn. So this talk is basically about NFC. Anyone heard of NFC? Near field communication, right? So it comes in like new phones like Samsung Galaxy S3 or the Nokia N9. So what this talk is about is like we'll be discussing different attack methodologies using NFC. So this is something about us. Like we are information security researchers. We work in a company, like we have our own company named XYSec. We do penetration testing and application security stuff. And we have also created a framework named as Android Framework for Exploitation. It's written completely in Python. So that framework, what it does is like it can create automated malwares, like find vulnerabilities in your device, create POCs of your like what the vulnerabilities you have found. You could create POCs of that. And we have also found some bugs in famous websites such as Google, Apple, and all. Okay. So this is our agenda for today. Like first of all, we'll be having a brief introduction of what NFC is, like what are the protocols it operates, how it is different from RFID, and then we'll be having a look at the NFC stack, and then different protocol layers, application layers, and then various NFC attack methodologies, and then how to exploit Android phones using NFC. Okay, so what NFC is, it is like, it is somewhat similar to what RFID is. Anyone knows of RFID? Yeah, it is kind of same, like it operates in nearly same frequency range as RFID. So using NFC, what you can do is like, you have two phones and you have to transfer data from one phone to the other. Like you have to transfer your photos or the music. So what you do is like, you just tap two phones or bring them close enough and then the transfer will happen. So they have to be like almost close but not exactly touching in order to the transfer to complete. So just like Wi-Fi operates on the protocol, the standard IEEE 802. Similarly, this NFC operates on ISO 14443, and its operating frequency is 13.56 megahertz. And the operating range, as I said, should be small enough, like 5 to 4 centimeters.
So what are the communication modes? There are actually two communication modes, passive and active. So in my hand, I've got a passive NFC tag. So everyone knows about NFC tags, which you see in pantaloons. If you go to pantaloons, it's stuck in the clothes, right? So those tags doesn't have any battery, right? So what happens is the initiator provides the power, and the power is reflected back with a signal. So that is how passive tags work. Okay. In case of active tags, it's like when you transfer images between two phones, you tap the two phones, then the image from first phone transfers to the second phone, so initiator and target. So the both initiator and target simulates the NFC simulation. All right? Okay. Some technical stuffs. This is about NFC stack. So we have different kinds of protocol over here. The lowermost protocol is the physical characteristics of the NFC. As usual in Wi-Fi protocol, also you have a physical characteristics of ISO model or IEEE 800 whatever. So in this case of NFC, you have ISO 14443, and these are the protocols which have been followed. And above the physical characteristics is the RF stack. Okay, that's the radio frequency stack, and above that is the initialization and anti-collision protocol activation. So this is like whenever you're transferring an image from one phone to another, you should know that two phones cannot communicate together at one time. So if one phone is communicating to other phone, the other phone should receive it. So it's kind of anti-collision measures which are there. In case of LLCPs, like if we go up to the next stack, that is protocol, there are different kinds of hardware protocol. For example, this one is MiFi Ultra Light Protocol, this stack. The one which you see in pantaloons or any shopper stop malls, those are normal MiFi protocol, not ultra light. Okay. And then we have LLCP. LLCP is actually what we use in phone, Android Beam. That is what we beam through from one phone to other, right? Then we go to the application protocol. In the application protocol, we have we can summarize the first top four protocols as an application protocol. Mainly, we are going to concentrate on NDEF, that is NFC data exchange format. So, what data are being exchanged from one device to other device during NFC transfer. Okay. Uh, Okay, so this is the protocol layer, consists of a physical layer and RF layer, as I said, and these layers are focused on physical aspect of starting communication. And if you go to the protocol layer, this is the type 1 protocol layer, Topaz. This has a format of Topaz protocol. It has read all, R all, read, write with erase, write with non-erase, then resegmentation, read 8, write E8 or write N8. Why am I telling you all these? Uh, I'm telling you all these because it is very useful when you when you do a fuzzing test on NFC-based stacks. Okay, and this MeFair Classic, that is what which was used in credit cards before. So it used to use the NXP proprietary security protocol, but this encryption was reverse engineered and broken in 2007. And then we have MyFair Ultralight, which I have in my hand. And this data is accessed using read and write command. That's it. And then we have LLCP, that is P2P, peer-to-peer protocol. So that's what we do when we touch two phones together and the data gets exchanged. Okay, so then we are going to move on to NFC application layer. Okay, so this is a bit interesting. Uh, NDEF or NFC data exchange format is what primarily consists in the application layer. So it's a simple binary message format, and I'm going to show you a sample NDEF format for text. Okay, so this is the hex file, which is received from a tag or from a phone to another phone or from a tag to another device which is receiving. So first define what is the first hex. It is the starting of the NDEF message. So it's say NDEF message start. Then 17 is the payload length. I'll tell you which one is a payload. D1 is the what type of NFC it is. Is it MB, ME, or then we have TNF, which is NFC forum well-known type. And then we have type length. Type length meaning you can have U type. U type is for URL. T type is for text. So in this case, type length is 1. And what type it is? 54 is the meaning of type T, which is a text. Okay. And then we can go to status byte. Status byte actually tells you what kind of data is it. Is it encoded in English or Espanol or whatever? So in this case, we are 656E means EN. So that's a language code for English. So 02 is the length. So EN is 2 bytes. So and then we have the message. So in this case, the message is hello ClubHack exclamation. So this message is in text format, right? And the end is FE. So FE is actually the end of terminator. Okay. So Android NFC stack.
So basically what happens like when you bring two phones closer enough to exchange data using NFC, what is like we have three different parts in the Android NFC stack. The first is the kernel, second is the services, and third is the tag itself. It may be Topaz, it may be MyFair, or it may be MyFair Ultralight. So first of all, like when you bring the tag closer to your phone, the kernel will load the drivers, NFC drivers obviously. So the driver is libpn 544 underscore fw.so. So once the driver is loaded, it calls the necessary service for the NFC. So the service here is com.android.nfc. Like in Android, what happens is like whenever you define a package name, it has to be something like com.something.something. So here we have com.android.nfc. So in com.android.nfc, we have three parts: libnfc underscore ndef, libnfc underscore jni, and libnfc.so. So ndef will contain the NFC data exchange format, the JNI will contain the JNI part, and the rest of all will go to the libnfc.so. So if you bring a tag close to your phone, the ndef part will reside in the libnfc underscore ndef. So that is our main target. So suppose you want to fuzz NFC, like you want to find bugs in the NFC stack itself. So you have to concentrate in the libnfc underscore ndef.so. So what I just showed is like, This is the main text like 68, 65, 60, and then at the end we have FE. So this is whole of the text in hex format. So for suppose you want to fuzz NFC, so what you could do is like you could manipulate or modify this hex like hex strings and then pass in some random values like non-existent values like don't end it with FE, end it with something else. So in that case,
Or else what you can do is, for example, the payload length is over here 17. What if I increase the payload length to 18? What happens? So you can fuzz all these, properties over there in NFC. Okay.
So what will happen then is like com.android.nfc will show you an exception or it will crash. So you could just view the logcat for that exception like null pointer exception or look for use after free bugs. So next is the attack vector ATM card skimmer. So what happens in the ATM card is it isn't that much popular in India, but in US and all that countries, you have the credit cards with NFC enabled, right? So the NFC enabled credit cards will have the NFC logo at the top of them. So for suppose a user comes to the ATM machine and put in it the NFC enabled card. So what the attacker could do is like he could place a NFC tag at the ATM machine and he could receive the NFC tags or the NFC data from all of the cards which have been inserted in the ATM and he could collect it over a period of time. Like suppose he places it to the ATM in the morning and in the night he like pulls back the NFC tag and like reads all the data from the credit card, right? So then we have AID selection. Like some of the major credit card companies like Mastercard and Visa, they have their AIDs such as A0 and then the following number. So if you have A0, it means that the card is NFC enabled, right? So AID is basically application identifier. And then we have EMV decoding. Like the credit card, what it does is like it encodes the data, like sensitive information of the credit card to a particular format. That is EMV, Europay, MasterCard and Visa. So if you have collected the data from the credit cards and if it is encoded in EMV, what you could do is like you could take on that data and put it in an online decoder and then get the raw format, like the original credit card number. So how to protect? Like if you are a financial organization or if you're a credit card company, you could like have some standards such as PCI DSS, and then you could use a better wallet. What do you mean by better wallet?
Anyone, any idea? What's a NFC wallet?
No, not exactly. Like you have that NFC enabled credit card in your phone. So what an attacker could do is like he could bring his phone closer enough to your pocket, which contains the wallet, and he could just read your credit card information.
For example, I've got a phone over here
Yeah.
and he has a purse over there. So what I can do instead of pickpocketing his pocket, if he has an NFC enabled card, what I can do is that's it, and I get the whole data, right?
Don't take it in a wrong way.
So what we can do, either we can do it in Indian style of protecting it or foreign style of protecting. Foreign style is you can buy your what is it?
This one, yeah.
Yeah, you can buy this kind of NFC
Protection wallets. Yeah.
wallet. What it does, it has a kind of conductive material all over so that the NFC data doesn't get. Indian kind of protecting it is yeah. The Indian type of protecting it is just use a foil around the NFC card. I mean, that's it. It's not gonna be hacked then, right? Okay. About the NFC relay attack, I'll show you one example. But since my screen, the screen share is not working, okay. First you tell. I'll bring my file.
So in major companies like suppose you're an employee of TCS or something, you have that NFC enabled cards. Like whenever you enter your organization, you have to give the attendance using that NFC enabled card. So what an attacker could do, or like take another scenario, like someone is using an NFC enabled credit card to pay to a payment terminal. So what an attacker could do is like he could read information from the credit card first of all, and then he could use his phone as the NFC carrier to pay to the payment terminal from the victim's card, right? So actually what is happening is he is using the victim's card to pay to the payment terminal using the NFC data, right? So
So I'm gonna give you one example of how it can be done. Like, one second. This which I have in my phone, and I can just see what data which are there, right? And then I can use my phone as a relay to this. And instead of carrying my card, all I can do is I can just carry my phone, and I can just put it over there, and that acts as the same thing. So I've got the whole data over here. So data as hex format. You can see all the data over here. These are the protected fields, and I don't care about protected fields. All I just need to do is emulate this data, go to my company without using a card. I can just flash my phone, and that's it. I get an entry. So it's a kind of relay attack. Get it? Okay. Now this is NFC poster skimming. Anyone heard of this? Actually, it is not common in India. Uh, while I was in US for a conference, there I saw at airport there was a poster. Okay, so it was there like tap your phone, Samsung Galaxy S3 over there, and download a free ebook, right? So you tap your phone and you get a free ebook. But I can put something behind the poster other than that, and I can just attack your phone without you even knowing what happened, right? Okay. So, so we are gonna talk about leveraging NFC for Android-based vulnerability. Since we are gonna concentrate on Android devices, there are many other devices like Nokia and Blackberry. No, Blackberry did not come up with NFC yet. So, anyways, Nokia is there, and then there is Migo framework. So we could have talked about that, but since everyone over here is using Android, I guess. So, and it's easy for you all to understand. So I'm going to talk about the Android-based vulnerability which exists in present scenario. Okay. Okay. So first, before moving forward, what I'll do. Sorry, my screen share is not working. Otherwise, I could have showed it in the projector. So instead, what I'm going to do is, first of all, I'm going to write some tag over here in my NFC tag. Okay. So in this case, if I just write, I mean, for example, an SMS tag, anything, and then message anything, and then if I just click on it, it's going to write it in my tag as a text. Okay. Now the security feature of what Android implemented is like, if I put my tag over here, it's going to first go through this application. Like, what do you want to do with this data? Okay, so I need user interaction to select what do you want to do. You want to send an SMS or send a WhatsApp SMS or whatever, right? But we don't want user interaction. We want everything automated. So there are certain protocols which are there, which are automated protocols. For example, there is a www based protocol. For example, if the NFC tag is written with a web URI, then this app won't start. The browser will start automatically, right? So, for example, I'll just give you one example. It's going to be fast. Okay, I'm going to type over here and I'm going to just write a URL, my company URL, xysec.com. And then I'm just going to write it in my tag. So it's written. So this time what I'm going to do is I'm just going to tap the tag and the browser opens without going through any other applications or anything. So the browser opens and the page opens, right? So, so what can we do with this? Like, what can we leverage in this format? Like, what can we do? We can use any browser-based attack with NFC without anyone knowing about it, right? So, for example, okay. For example, if we do NFC new kind of malware which we had developed, what it does is it proxies out all the requests which goes through the browser into my application. All, I mean anything, YouTube.com, Facebook.com, Twitter.com, anything. So yeah. So what I'm going to do right now is I'm just going to run my program over here. This is the custom URL receiver. So I'm just going to run this program. Uh, This tag contains the URL of my company, xysec.com. What it should do? It should open a browser. Agreed, everyone? So what I'm going to do, this time I tap the tag right over here. Instead, it opens this application. Okay? Okay, let's see about some good stuffs. I mean, much more interesting, juicy stuffs. For example, if we just write facebook.com as the URL, facebook.com, and then we tap the tag. So it basically writes the tag as facebook.com in the tag. And then if I just tap the tag, instead of opening facebook.com in an URL, what it's going to do is it's going to open that particular application without any user interaction, right? So you can see the vast attack surface which we can have over here. We can open a phishing URL. We can open a phishing page actually instead of opening this URL. Anyhow, this code is already available in GitHub. You can go to github.com/afe. There are many number of repositories over there, so it's going to be shortly uploaded. So you can see through this, like how is this being leveraged. If you guys have any question, you can ask. Anyways. So this is what happened. NFC tag, any URL, no interaction needed. Instead of opening the browser, it opens up an application. So that is one of the attack vectors which we can use. Okay. Anyone heard about the Samsung Galaxy S3 USSD attack? What? Yeah, absolutely.
Ravi Shankar in Eco Party.
Ravi Shankar in Eco Party has discovered this USSD bug which exists in Samsung Galaxy S3. What happens is the browser opens the tel colon format URI, and instead of giving what is a tel colon URI format, it opens the dialer. That's it. So instead of asking the user's permission to call or not to call, it just pastes the number in the dialer. So what happens if I just give tel colon 1234, right? Then we flash the tags. What happens? The dialer pops out and the code is written. So how can we exploit it? It's still the user needs to click on the call button, right, to call. So what is there? That there comes USSD, right?
So what we have at xysec.com/ussd.html is a tel colon. Like suppose we want to get the IMEI number, we'll place a USSD code star hash 06. Everyone knows that
What does star hash 06 do?
to get the IMEI number, right?
It just gives the IMEI number, right? Okay.
So we'll write the tag with tel colon star hash 06 and place it in xysec.com/test.html.
So this page is already there, xysec.com/ussd.html. Please do not go to this URL using your Samsung phone, otherwise your phone is going to get resetted. All right. There is another link over there. You can just go to instead of ussd.html, you can just go to test.html. That will just pop up with your IMEI number. So what I'm going to do is I'm just going to write this xysec.com/test.html. So I'm just going to write this in the tag now. So it did right. Okay. I'm going to exit this application. Let's see what happens. The internet is connected. Okay, sorry, I need to close the custom URL receiver, otherwise that's the first application which is going to start. So I'll just remove that. Okay. Since this has been uninstalled, now the browser is going to open. So this test.html opens up automatically without any user interaction. And you can see the IMEI code did not come. Okay. It's star hash 06 hash, right? I don't know. No, it shouldn't be patched because right now this is the old version actually. Anyways, uh, oh, it was working. Hold on. And this gives a lot of trouble. Okay, here it is. It's not patched. All right. So I can see the IMEI code of my phone over here, but now let's be evil. This phone is not mine, of course, it's my girlfriend, so I can reset this phone, so not a problem. So instead of writing test.html, what if I write ussd.html? It contains the S3 reset tag, right? So again, I'm just gonna go over there and I'm just gonna write in the reset tag over here, right? URL will be xysec.com slash ussd dot html. Sorry, ml. So again, I'm just going to write it over here. Tag written. Let's see what happens to this phone. Opens the browser, loads the page, no user interaction required, and view. It's going to reboot in factory mode. God, the phone is dead. So it's just gonna reboot in factory mode. So all I wanted to show you is it's not necessary that NFC is under attack, right? It's like you can fuzz the NFC and you can crash many applications, but you can use the NFC thing, you can leverage the NFC to attack other properties, software, or anything. By the way, does anyone know what exactly is this exploit doing? Anyone? You? No. Okay. The what happens is there is a vulnerability exists in the Samsung dialer. What it does is it does not pops out before dialing. If it gets it from any web browser, it does not pops up for user confirmation like should I call, should I call, right? So what it does, just starts the application. So it just dials the number and it pops out. Okay, if the number was just 1234, then user interaction was required to press the call button. But since it is an USSD code, once you just write the number, it just comes automatically, right? Okay.
So we have also developed a framework named as Android Framework for Exploitation.
Anyone knows about this framework?
No? Okay, one
No
of
one
you.
knows about it.
Oh, okay. So this framework is available at ap-framework.com. And what it does is like I've already told you, you can create malwares, find vulnerabilities in application as well as the Android platform itself. You could use it to fuzz various drivers as well as the NFC driver. So all the NFC modules and all the other exploits which we have will be created as a module section in this AP framework. So you could download it for free from the ap-framework.com. So we have already released the private version of this framework, and the public version will be releasing in Black Hat Abu Dhabi next week. Okay, so that's all. If you have any queries, you could mail us at security@xysec.com.
And I'm sorry for those people who expected to see some buzzing. We don't have time.
Okay. So any questions?